Welcome. Today we solve find all numbers disappeared in an array 2. The question is simple. Inside the inclusive range from lower to upper, which integers are missing from nums? Then we group consecutive missing integers into ranges. We will go slowly from 0 with full dry runs and code. What are we given? An array nums that may contain duplicates. An integer lower, the start of the search range. An integer upper, the end of the search range, inclusive. We must return all missing numbers inside that range as contiguous ranges. If nothing is missing, return an empty list. What is a missing integer? A number x such that x is between lower and upper, inclusive, and x does not appear in nums. Numbers outside the range do not count as missing for this problem. Even if nums has values outside the range, we ignore them when deciding what is missing. Consecutive missing numbers must become one range. 1 and 2 become range 1 to 2. 4, 5, 6 become 4 to 6. A single missing 8 becomes 8 to 8. 10, 11, 12 become 10 to 12. Always return pairs start comma end in increasing order. Example 1 setup. Nums is 3, 9, 7. Lower is 1, upper is 12. On the number line from 1 to 12, 3, 7 and 9 are present. Everything else in that range is a candidate for missing. The expected output is ranges 1, 2, 4, 6, 8, 8, and 10, 12. First list every missing integer. Present values in range are 3, 7, and 9. Missing values are 1, 2, 4, 5, 6, 8, and 10, 11, 12. Duplicates in nums do not matter because membership is yes or no. Next, we compress consecutive misses into ranges. Build the ranges. 1 and 2 become 1 to 2. 4, 5, 6 become 4 to 6. 8 alone becomes 8 to 8. 10, 11, 12 become 10 to 12. Final answer, 1, 2, 4, 6, 8, 8, 10, 12. Example 2. Nums is 1, 1, lower is 5, upper is 7. The value 1 is outside the search range, so it does not fill 5, 6, or 7. Missing numbers are 5, 6, 7, which form one range 5 to 7. Answer is a list containing 5 to 7. Example 3. Nums is 2, 3, 5, lower is 2, upper is 3. The range only cares about 2 and 3, and both are present. 5 is outside this range, so it does not matter. There are no missing integers, so the answer is an empty list. Key insight. Put all nums into a set. Then asking, is x in nums becomes very fast. Walk every integer from lower to upper. If x is not in the set, it is missing. A set also removes duplicates automatically. This is simple and fast enough for the constraints. We can build ranges in one pass. Walk x from lower to upper. If x is missing, start a streak or continue the current streak. If x is present, close any open missing streak as start to x minus 1. Keep the start of the current missing run. This streams ranges without needing a giant missing list first. Walk dry run start, for example 1. Present set is 3, 7, 9. X equals 1 is missing, so start becomes 1. X equals 2 is missing, streak continues. X equals 3 is present, so close range 1 to 2. X equals 4 is missing, so start becomes 4. Continue the walk. 4, 5, 6 are missing, then 7 is present, so close 4 to 6. 8 is missing, 9 is present, so close 8 to 8. 10, 11, 12 are missing until the end, so after the loop we close 10 to 12. Always flush the last open streak. Final answer matches example 1. Algorithm steps. 1. Put nums into a set. 2. Start is none. Answer is empty. 3. For every x from lower to upper inclusive. 4. If x is missing and start is none, set start to x. 5. If x is present and start is open, append start to x minus 1, then clear start. 6. After the loop, if start is still open, append start to upper. 7. Return the answer. Time is order n plus the size of the range. Here is the full Python solution. Build a set from nums. Scan every x in range lower to upper plus 1. When a missing streak starts, remember start. When a present number appears, append the closed range and clear start. After the loop, if a streak is still open, append start to upper. For example 1, this returns the 4 ranges we dry ran. Code walkthrough. The set gives fast membership tests. The variable start tracks the beginning of a missing streak. On a present number, we close start to x minus 1. After the loop, we close any trailing streak to upper. A single missing x naturally becomes x to x. Pattern: open, extend, close. Alternate idea. Collect unique present values inside the range and sort them. If lower is less than the first present, add lower to first minus 1. Between consecutive present values A and B, if B is greater than a plus 1, add a plus 1 to B minus 1. If the last present is less than upper, add last plus 1 to upper. Same answer, different walk order. Useful when the range is huge, but few values are present. Edge cases. If every number in the range is present, return empty. If no nums fall in the range, return one big range lower to upper. A single missing number becomes x to x. Duplicates are handled by the set. Values outside the range are ignored. Always think carefully about both endpoints, lower and upper. Key takeaways. Missing means inside lower to upper but not in nums. Group consecutive misses into start-end ranges. A single miss is still x to x. Use a set for fast present checks. One scan from lower to upper builds all ranges. Flush the last open streak after the loop. Ignore nums outside the range and return empty when there are no gaps. That is, find all numbers disappeared in an array 2, explained from 0.